Electromagnetic waves. Okay, you will recall once again the actual four equations are there. Okay, time varying or the statics, 4 plus 4. Okay, it means any one new time. Statics means you will take this when time is equal to 0, then time is there means you will take the previous one. These are the four equations. These equations are for the electric and magnetic phenomena, the way of Newton's law of mechanical phenomena. Now we are aiming at the proving an amazing result that the time varying field can be propagated as a wave through the free space. Through the free space, a free space is the one where the density of charge density will be the 0 and current density will be the 0. There are no free charges and there are no electric current induced voltage. When the Maxwell did this, there was absolutely no evidence, either the experimental or theoretical, regarding the existence of such waves. Thus, his prediction of the existence of electromagnetic waves purely as a deduction from the theoretical results is considered as one of the great intellectual triumphs of all times. Therefore, the rate of change of magnetic field has a non-zero value, then the del cross or the curl of electric field is non-zero, but the electric field must be the function of position. Therefore, further, the rate of change of magnetic field is not a constant, but it undergoes the changes with the time. Then, as per the same equation, the rate of change of change, the curl of or the del cross E must also be the vary with the time. This means to change the time, changing the rate of change must be a function of time. Okay, so by using all these things, okay, we are going to discuss here what is that. Okay, the idea that changing the magnetic field gives rise to an electric field, in which the changes in terms gives rise to magnetic field, forms the basis of electromagnetic waves propagation. And now for your syllabus we have a equation or a derivation of equation for the electromagnetic equations in the differential form of free space in terms of field. We are going to discuss on that. Let us start for the equation. What is the we are going to discuss the equation, wave equation in the free space. Where? In free space in terms of field. Okay, let us consider the Maxwell equations once again. Del of H, del cross of H is equal to J plus dou D by dou T. We will consider among the four equations these two. One, or del cross E equal to rate of change of magnetic field. Okay, into T. Okay, these are the two equations are there. But we know that D is equal to epsilon into E is there. The magnetic field is equal to mu into H is there. These are the fundamental values are there. So same values, for example, same values you are going to substitute or rewriting the equations once again. Rewriting the equation, these two equations, one equation two, by using this. How? Write as it is. Del cross H. Okay, del cross H is equal to del cross H wherever the D is there, no, J as it is, J plus, okay, dou D is here, you take it, dou D instead of D you write F only. D can be written as, okay, what is the epsilon into dou E by dou T, one equation it will be there. And del cross E can also be written as, okay, del cross E minus dou of B is equal to mu of H, mu taken outside, then H into D. These equations we will write. Okay, so these are the two equations, 3 and 4. This is 1 and 2 and 3 and 4. This is. Let us obtain the wave equation in terms of electric electric field, for which we must obtain an equation relating to the spatial coordinates of electric field to its time coordinate. This is done eliminating by the electric field. This is done by eliminating the electric field. Done by the eliminating the magnetic field, that is H. Okay, between the two equations, this in this equation, by following way, by taking the curls on both sides for the equation here, equation. What is the taking the curl on this equation? This, what is that? Del cross E. Okay, we am applying the curl for this. Okay, this whole equation, then equal to, because we are going to eliminate the H. Okay, right, minus U dou by dou t, okay, then this dou of h, dou I am applying, dou post dou applying. Now, okay, as per the vectorial form, okay, as per dou of dou cross e, dou of dou cross e is equal to dou of, okay, dou of dou, wait, dou into dou dot minus dou square e, okay, from the vector analysis. This is having the simplification for the vector analysis, no need do write directly. We know that according to vector analysis we will get this equation, dou cross dou cross into dou cross e can be written as in this fashion, alright. Okay. Or dou of, okay, the dou of dou e can be written as, okay, we know that, what we know, dou of rho d can be written as dou rho of v, okay, or dou of e can be written as, okay, rho of v by epsilon, wait, epsilon, because d is equal to, what is the d is equal to value, is d is equal to value is there, d is equal to d is equal to, e is equal to value is epsilon by d is there, okay, we are substituting the Maxwell equations, okay. Therefore using these fundamental equation we can rewrite this equation. What is that? Dou, okay, dou of v, dou of no, dou del of e can also be written as, del of e, this rho v by epsilon 1 minus dou square into e as it is, right. Now this equation and this equation, if you compare this both, so what will write, rho of rho v, del of rho v by epsilon minus rho square of e equal to, wait, equal to minus this, minus, compare this, minus u of dou t into del cross h, this will comparing this equation and this one. Using this equation right hand side, then what will write here, dou of rho v into epsilon minus dou square into e is equal to minus u dou by dou t, okay? This can be written as, okay, by the first, this can be written as by the equation 1, j plus of, okay, epsilon into dou e by dou t, okay. I removed the h, okay, instead of dou cross h I am writing in the form of electric field, that's my intention, okay. Therefore dou cross e, okay, e, and take it here, it is a minus, it means plus, wait, plus, it is plus, okay, mu dou of into epsilon, okay, dou of dou t square, okay, dou square into dou e, dou square e equal to u of dou by dou j by dou t, okay, plus, okay, it will go here, okay, it will go here, rho v by epsilon, okay. This is the equation 5, okay. Now wait, now the left side, what is the left side, this left side, okay, of the equation of characteristic for the form of the wave equation, the solution of such an equation represents the propagation of wave, the right side represents the source which are responsible for the wave field, the charge and the current, and the equation of this equation represents the wave equation of electric field, okay. There is no magnetic field, h is limited electric field, okay. Hence the medium with the constant mu and the epsilon, so it is a homogeneous and isotropic medium. If we consider the free space, if we consider this is a free space, okay, free space, okay, free space means rho v is equal to 0 is there, or j is equal to 0 is there, the same, okay, rho v is equal to 0, j is equal to 0, rho v is equal to 0 and j is equal to 0, then what remains, dou square e by e minus mu of epsilon d square e divided by dou t square is equal to 0, because this j is equal to 0, this whole thing, rho v is equal to 0, this whole thing is equal to 0, so this is for the free space.